Alright, just going to review here quick what our parent functions are. Okay, we're going to go further into graphing rational functions. Okay, and then I have a worksheet on graphing limits of rational functions. Okay, so Liv's going to find out here by the end of the period she should have turned around and went the other direction, because your mind is going to be one that you're going to have to think. Okay, so if you're not awake yet, okay, it's going to start going here. Okay, so it's about putting together stuff that you did know, okay, or at least I'm hoping you remember, with some of the stuff you should have got last year, which you didn't because of time, with the limits that I've taught you this year. Okay, all in one lesson. Okay? Alright, here we go. Graph. That's x equals x squared. Flip it up when you got it. Remember, you have the graph side on the other side that you can use. Okay, so we know this one right over here is going to be, okay, just a simple, quadratic. Okay, oops, just like that. Okay, go ahead and graph f of x equals the square root of x.
We can't use notes, man.
No, this is just stuff that you know. Mr. Johnson, where are you getting on your seat? Were they right here?
Why would you say that? Are you actually?
Sorry. Well,
I thought you liked this.
Why
did you do that?
We'll have a timeout here. We'll all go sit in different spots. Okay? Alright, this one right here, square root of x. Okay? Just like that right there.
No.
Okay? Okay, graph that. That's not the same. Yes, it is. So, this minus right here, rocks is it? Okay, and this minus right here, roids that rocks. Okay, so that green was the equation that had the double negative. Alright, go ahead and graph f of x equals x cubed. I think you're trying to get it.
So it's
Yeah, I think you're trying to get it, but it's not very good.
what? Wait, what? No, that's not. What? What do you mean? Is that not
You're doing, which one? Yeah, that one.
Absolute.
Function.
Absolute value is
Did we just?
this.
That one right there.
Absolute value is straight lines.
No, absolute.
Okay, cube, okay, is going to go like that, and then down like that. Okay, that's a cube right there. Okay, some of you try doing it in one swoop, okay, and you get some funny little things that kind of go through there. Okay, so I always do it in two swoops. So I get that one, then I get that one. Okay, alright. Okay, an inverse function. 1 over x.
I'm thinking.
Guys, we did this one the other day.
Oh my god.
I don't even remember when I had to address this.
The other day was like the last week.
What's the one that goes like this?
So,
Oh, sorry, and the other day was blind day.
We got
Wait,
this.
Monday?
Well, maybe we didn't get that far. We didn't get that far.
No.
Okay.
Yes.
Okay, this one right here has asymptotes. Okay, and it goes there and there. Did we get to those?
Yeah. No, I
I thought we just got to that because I talked about girls. Remember this one? It has, you know, those things and, you know, it's being dumb again. Okay. Absolute value of x.
So, ooh, for this one, I know.
This one we got.
Just kidding.
Alright. Woohoo! Wow, look at this! I take you all the way back to algebra 1 and we got it.
I mean, that's the easiest one to remember.
Oh. Okay, this one right here. It's the V. Up and up. Okay? I think this is my last one. There we go. Get that into L.
So you like don't know it.
F of x equals x. This is the easiest one. Oh my here. Now I'll make it easier. F of x equals 1x plus 0.
Did I do it?
No.
No? I didn't do it.
I didn't.
Y-intercept is 0. Slope is 1. Rise 1, run 1, rise 1, run 1. There you go. Good job. Alright. So, graph that. Maybe you might want to start using the graph side of your whiteboard here.
So when you were, how old are you when you started?
Okay, I think we're right. And then so
Junior. Okay, look, this is from
and the A is less than Y, so it's I think it's compression, right?
14, 8th grade,
I think it's a compression.
7th grade.
You know, I got 2 options.
You can't see from there where your vertex is.
What?
Label your vertexes. I can't count from here. That's where you are. Label your vertex.
I did. What were you doing? You did 5. You did that positive. Oh, is that green? Is that it? Oh, I thought it was a 5. So, if it wasn't, it would have you. No.
No.
No?
Told you it's 2 years.
I'm sure about your vertex.
Well, then it'd be gone.
Okay, I know I've told you this so many times. If you guys can reflect back on the beginning of the year, okay, you said, I told you I'd say this so many times you'll roll your eyes every time I say it, it's n equal to 0. But you can understand by now why. Okay, so we have, you know, -3 over, we go 7 down. Okay, line of symmetry,
How much is
parent function. Okay, now that half. You got a 50-50 guess. Is it going to be skinny or is it going to be wide? Okay. Is that a vertical stretch, compression, or horizontal stretch or compression? It's vertical. Okay, stretches are bigger than one. Okay, so if it's a vertical compression, here's my hands, and I have to compress it. So I'm compressing it. Is that going to make it wider, or is that going to be making it skinnier when I compress it? Wider. Okay, if I want to pull it this way, pull it, that makes me skinnier here. Okay, so this right here Okay, is that graph right there. Okay? Alright, on that graph right there. Okay, find f of negative 2. I didn't ask you to graph f of x equals 2. I just said, what's the height of the function at negative 2? It's just like the quiz that we did. It's just like all your limits stuff that we've been doing. Okay, speaking of limits, that's what we're coming up here next week. Okay, find the limits of it. Okay, f of negative 2. That means take, okay, x. Where a negative 2 is right here. Replace it right there with x. We have negative 2 plus 3. Okay, is 1. 1 squared is 1. 1/2. Okay, times 1 is 1/2. 1/2 minus 7 is negative. So at negative 2, so if I go over here to negative 2 right here, does it look like when I go down to the graph down here, I'm somewhere right around here at negative, okay, negative 6.5? Is that what it looks like it is right there? Okay, I mean, I'm just drawing a sketch, but that's where this function is.
God bless.
What's the limit as it approaches negative 2? From the left. There's my car. Okay, we're coming in from the left. Okay, so here we go. We're on the road, driving. Okay, and right now we're at probably 9.5. Here we're at 7, 8, negative. We got to get over here to negative 2. When we come into the left, what's my height going to be when I get to negative 2? Oh, yeah, negative 6.5. Now if I change this to a plus, I come in from the right. Coming in from the right to get to negative 2. What's my height going to be for this limit as I get to negative 2? Oh, if I erase this right here and I just say come in from the left and the right, is it still negative 6.5? Yeah, I mean they meet up. This car would come in from this way. This one, they meet up at the same spot. Okay, limits are very similar to these, but not always exact. If you have like pieces, these are going to change as we get like piecewise functions. Okay, on Thursday. So this is negative. Okay, 6.5. All right, so then erase, graph that. Absolute value of x plus 6 minus 3. Dave, you got it?
Yeah. Bigger than one.
Okay, so I set that equal to 0 again. Okay, subtract 6, I get x is negative 6, so my vertex, okay, is at negative 6, negative 3, over negative 6, down negative 3. And make sure you guys label your vertexes as you do this. Okay, here's the normal parent, goes up 1 over 1, up 1 over 1. That's a normal parent right there. What is this 4 doing to the function? Is it making it wider or is it making it skinnier? Skinnier. Okay, so my function is going to be skinnier. What's f of 4 going to be? Put that up on your board.
That's a good question.
So if I come over here and go to 4, 1, 2, 3, 4. Oh, it's like way up here. How high do I get at 4?
7.
I don't know.
Brad,
I got 37.
where did you guys get 37?
I don't think I did.
When I find f of 4, the 4 has to go right here into the x. That 4 gets substituted in for x. What is 4 plus 6? 10. What's the absolute value of 10? And then 10 times 4 is? 40 minus 3 is? Yeah, so I'm way, way up here. I'm way up here at 37 for my height. Okay, way up there. Okay, now, next question on that is, okay, I want to come in and find the limit, so find the height, as you approach -6 from the left. As it approaches -6 from the left. Do you have to plug -6 in right up here?
No.
Isn't it already one of your points that you've plotted? The only point you plotted? Okay, so I have my, okay, wonderful car right here. Okay, coming in, okay, from the left, coming in here, gets to -6, and what's my height? -3.
What?
Whoa.
Is it going to change if I would have came in from the right side here? No, there's no holes in this graph. There's no spots. You guys remember how part of your functions used to look like this when I was doing the quizzes? The graphs were all chunked up in pieces. That was when I was really trying to just teach you flat out limits. Okay, now I'm trying to recoup some of your information that you have from graphing and put together the limits with it. Okay? Alright, you can go get your little graph paper out I believe I gave you the other day, and you can add this one to it, because this is a new concept. Okay, right here. I don't think we got to this one. We did not. We didn't get anything like this. Okay, so we've learned how to graph absolute values. Okay, we've learned how to graph quadratics. Okay, and we get to learn how to graph this. If this doesn't bring a smile to your face at 8 o'clock in the morning, I don't know what will. This has to wake you up right away in the morning and say, oh, life is so good. Oh, you guys don't think that way when you wake up? I mean, I wake up every morning thinking, oh, I'm going to go do some more math. Like recap, the students are going to love me today. Yes. Do I have more graphing paper? I do. All right. Anybody else need more graphing paper?
Okay, ready?
Tickle eraser.
I just tempted it like my back.
All right.
It's an emergency. Dude, it just happens.
Does it look like something you've ever graphed before?
Goldfish, I don't really care.
Okay, if I erased the bottom, would it be something that you have graphed before? Some of you don't want to say you have, but have you graphed quadratics before?
Yeah.
Yes. We found line of symmetries with negative b over 2a. Okay, you've done those things before. You've done completing the square. Okay, you can complete the square of this stuff right here. Okay? But this right here, if I actually told you that that right there's a line,
This is
just a line, would you believe me?
Yeah,
No.
but what if it happened?
Okay, so this part right up here on the top. Okay, I'm going to come up here and I'm going to say, oops. That part right there, factor. We're going to simplify this. All it does is reduce. Okay, so we're going to factor it. Close. Pretty damn close, yeah. I mean, the one part that I have to teach you new is the part you don't know. But yeah.
Dude, that was gone. I did the other graphic.
I actually have it written down.
Okay, so what happens here, and this is the part, okay, that, okay, I'm hoping is not the hard part. Okay, but unfortunately, factoring is something some of you have never become experts at. Okay, it's something that as we continue on, those of you that do continue on, here is the better you get at this stuff, the better the higher level math is. Okay, so when we look at this right over here, okay, and I don't know how your algebra teachers always taught you, if they use the box method or if they use, okay, any other methods right up here. Okay, I always use the double and half method to find out, and I have to find out which terms will add or subtract to give you 7. Well, I know that one right there doesn't add or subtract to give me 7. I know that one right there doesn't add or subtract to give me 7. It gives me 3 and 9. Okay, but this one does. So if I put the 2 there and the 9 there, here's the problem though. If you add them together, that gives you 11. And I have to have a positive 7. So that means I need this one to be a positive and that one right there to be a negative. And since that's a negative 2, and I want that to be negative 2x times x, and I need this to be positive 9. And why is that helpful?
Cancel them out.
Yeah, this cancels with that right there. And you're left with this function right here. Is that graphable? Okay. Now there's only one exception that you're going to learn new. When you cross something out, it actually creates something in the graph. Okay, and this is something that you may not have got to in Algebra 2 last year, more likely not. Okay, but when you cross something out, okay, it's going to create something here. So first of all, let's come up here and graph this. And I have my y-intercept at -2. Okay, I rise 1, run 1, rise 1, run 1. Okay, and here is my graph, okay, for that function. Ooh. Now, you have just graphed it. Now, ignore everything that's behind me and evaluate that function. You always evaluate the original parent function. You always do the limits of the original function. This right back here was just to help us get the picture. Now, anything that we evaluate, we have to do it from the original function. Very, very important. So if I come over here to -9, how low am I going to get down here? Well,
He said it.
yeah, this part right here I can see negative 9 squared plus 7 times negative 9 minus 18. That right there is going to give me, okay, 81 minus 63 minus 18. Okay, and, okay, negative 11. But I have a problem with that. There's still something on the bottom. What is negative 9 plus 9? And what is negative 11 divided by 0? Yeah. That's because in this function, there's a hole in the graph. So the graph is broken. You guys remember how I put those little oval or open circles on the first day when we were doing the quiz on limits? Okay, that's what's happening in this graph. When you cross something off in a graph, like I did right here, that when I cross that off, it creates a hole in the graph. So what I have right down here is that I get down here to 9, okay, right down here at this spot, I got a little hole right there. The hole, okay, is continuous going up this way. It's continuous, okay, going all the way down that way, okay, but there's a little, okay, spot right there, okay, that okay, it's supposed to. Yeah, anyway, that's supposed to be, that looks like it's at 10, okay, but down there negative 11. Okay, so what is the function as it right there? Okay, undefined. It does, that part right there, okay, is undefined. Okay, you can't divide by 0. Okay? Now, it's not, does not exist, okay? There's just an undefined limit, or undefined part. Okay, limits are the things you gotta take care of and see if they exist or not. Okay, so I want to evaluate that function, okay, at 2. Okay, so if I'm coming over here at 2, I want to evaluate that function and see what the height of the graph is at 2. Okay, so that means I got to come over here and instead of putting in negative 9 here, I'm going to put in, okay, positive 2. Positive 2 into the graph. That's going to give me right here 4. Okay, plus 14 minus 18. Oh, that's 0 on the top. And if I put in 2 down here in the bottom, that's 11 there. What's 0 divided by 11? Is that undefined again? No. And you can see right there at 2, isn't it at a height of 0? Okay, but if I come in from the left, that means my car, okay, is right here, and it's driving in, okay, from the left. Okay, can I have a limit there as I drive in from the left? Okay, so there we go. We have a height, okay, of 0 when it comes in from the left. Now, how about negative 9 as I come in from the right? So here we go. We're coming down this way, down this way, down this way. And I come in to negative 9. What's the height of the graph as I approach? Not when it equals it. What's the height as I approach negative 9? Negative 11. Okay? This one right here can have a function at, it can have a height as it approaches it. This right here is saying, what is it as I'm right there at that spot of negative 9? Well, there's nothing there. It's a hole. Okay? But as I get down here and I meet up with that spot, and nobody's coming in from the other side, and when I meet up with that, that's going to have one of negative or 11. Okay, scale 1 to 5, where were we at on that graph? Alright. Okay, go ahead and sketch a graph of that.
Uh-oh.
Either way, I don't care. We've already done it. You guys, I'm just making you put it in your notes now.
Are you sure?
I'm sure. Because sports things.
Yeah. She's right. She has a good dad that teaches her about asymptotes.
Uh-huh.
That's right. You're not in trouble. Right. I had to have that talk with my daughter before prom. Yeah, it's an embarrassing one, I know. But just with me and my daughter, yeah.
Yeah, I would have been really mad.
That's right. We had that talk. I said, Peyton, you know, boys are like asymptotes. And by the time I say that, she just looks at me and rolls her eyes. You guys got to realize I live with this girl, so you think I'm crazy here in class. I got and my daughter has that personality. So yeah. So she just kind of looks at me and rolls her eyes and walks away. And hey, go talk to your
That's a lot.
All right, so we have absolute values. Or sorry, we have these are called inverse functions. Rational expressions is what we're going to get to from this parent. Okay, and if I put in 1 right here, if x equals 1, so if I go over x is 1, aren't I going to be right there at that spot right there? Because 1 divided by 1 is 1. Okay, if I go to x is 2, I'm going to be at a half. If I go to x is 3, I'm going to be at a third height. So this is just going to get closer and closer and closer, but never touch. Okay, and the same thing this way. It's going to get closer and closer and never touch. If I put in x as -1, if I go over to -1, 1 divided by -1 is -1. Okay, I put in -2 and I get, -1/2. I put in -3, I get -1/3. Oh yeah, close, close, never touch. Close, close, never touch. Okay, I want you to find out, okay, what is the function? What's the value of f of I do. Yeah, I got a son who's sophomore at UNI. Peyton is a junior at Marion, and my youngest is a 7th grader at Vernon Middle School in Marion. 2 girls. Trouble. Right there. I'm sorry, boys are so much easier to raise than girls.
You are a boy.
No, girls. You guys have lots of drama. Okay, so yeah. I love you to death. I would not change having boys versus girls. Okay, but you guys are a little more maintenance. Okay. So here we go. We have 4. So we come over here to have 4 in there. Oh yeah, if I come over here to 4, I'm at a height of 4. Okay. Now let's approach 0 from the left. Okay, so I'm gonna have my little mobile right here. Okay, there we go. We have Gabe sitting right up here in the car waving at everybody. Okay, there we go. Gabe's driving along right here in the vehicle, but he has to come in from the left. So Gabe's right here on the road. Driving. And he's gonna approach. Okay, 0. Right here, 0. Will he ever get to 0? No, because then he starts going like this. How high does he get when he's getting close to 0? Yeah, how low is that? Down. Negative infinity. So, we don't have to get there, we just have to approach it. If I wanted a height, I'd say, what is it exactly? This is the exact height. This is as I get close to it, what am I getting? Well, this right here, is going to get to a height of negative infinity. Okay. Now, so we're going to come over here and, Jackson gets driving in from the right. Here Jackson comes in waving right here from the right. Hey, how you doing? Hey, you went clear down there to negative infinity. Where am I going to go? Oh yeah, I'm going to go right over here to positive infinity.
You're infinitely away.
Hey, let's go. Go. There's more. Okay, so here comes Kenny. Driving Okay, we're going to approach -6. Oh, but
No.
do we need another person to approach -6 if it's just like this?
Yeah.
Oh yeah, so Denver's going to come up here.
Uh-oh.
Okay, and here's his car. Okay, right there. Okay, there he is, smiling. This is his car right there. Okay, so Denver's going to come in from the left of -6. Okay, and Kenny, here comes Kenny driving into the. Whoa, Kenny's car just fell apart. Sorry, Kenny. Okay, you lost your head and everything. All right, here we go. Driving, and we got to approach -6, so they're going to meet up. Okay, right here at 1, 2. Oh, man, Kenny, you lost yourself again. 1, 2, 3, 4, 5, 6. Okay, what is that spot going to be as it approaches -6? Yeah, I put in -6 right there, and that's going to give me -1/6. Okay, for an answer. Okay. Nice driving, Kenny and Denver. You got there and you didn't even crash. Okay? Yes. If they're coming in from 0 from both sides, okay, that could be an issue there, yeah. Because they won't meet up, will they? Yeah. So this part right here, so the question that Kai had right here, okay, was if I change D right here, and I don't know if I had that, no, I didn't have that. If I change this just to 0, okay, that means that, here we go, we're going to come right over here, and Kai's going to come in from the left right here. Okay, and, okay, we're going to have Lexia come in from the right over here. Okay, well, she goes, woo, down here to negative, and Kai goes, woo, up here to positive. Okay, is there going to be a negative limit that, are they going to ever meet up with each other?
Oh.
So this one right here, if it's from the left to right, yeah, that can't exist. Right there. Okay? Alright. Scale of 1 to 5, how are we doing on graphing those?
Great, honestly.
Alright.
That room for special.
Alright, we're going to graph that one right there.
Is the whole limit is not existent? Like, you know, have you ever seen Mean Girls?
I think I kind of have, but
Like, you know, when she's like, the limit does not exist, is this what she's talking about?
I'll look it up because I don't know. I'll
You
go.
need to know these
You know, I'm going to go YouTube it right here in a little bit. Okay, because it has to be in there. Okay, while you're doing one of these, I'll go back there quick. Mean Girls. Limit does not exist, and I bet it'll pop up.
Yeah.
Okay, all right. That'll be our little break here. You guys are going to need a break, a mental break here in a little bit. Okay, because this stuff's going to blow your minds here, you know, as they continue to go up. You'll start getting headaches. Okay, so that'll be a good break. Okay? All right, here we go. That right there. How is, okay, okay, this part right here. What is this going to do, this x minus 3? Yeah, this x minus 3, when we did these graphs, okay, right back here, when I did these graphs, not this one, but when I did this one, didn't it just shift it? Left 6. When I did this one right here, didn't it just shift it? That right there, when it was, okay, x plus 3, didn't it shift it to the left? So that's what this graph right here on this one, okay, right here, that's what it's going to do. It's going to shift it, okay, in what direction? You got it? So we're going to shift that. So when I shift the parent, remember, we have an asymptote, okay, just like that. Okay, we have our graph that goes like that. We have our graph, okay, that goes like that. And I'm going to shift this whole thing, okay, to the left. 1, 2, 3, to the right. Is that 4? 1, 2, 3, no, that's 3. Okay, there's my new graph. So that's all this thing did right here was, okay, take that function and move it. So the first thing you're always going to do whenever you do this, okay, is draw the asymptotes. Okay, so the first part is, oh yeah, I have that vertical asymptote, it's been shifted. I'm not going to talk much about horizontal asymptotes because that really blows your mind. Okay, so that's like for another 3-day lesson. Okay, but right now we're just moving left, right. Okay, we'll eventually stretch and compress. Okay, right over here, because that's what this one right here. What did this one right here do to your graph right here? I had this one that I skipped. What would the 7 over x have done to this graph right here? Stretch it. If I stretch it, okay, if I change this to 7 over x like that, a stretch is going to make this graph, that 7 right there does that to the graph right there. So you draw the parent in there, okay, and then you do that right there. Okay, that's what that graph does. This one right here moves it left or right, the bottom does. Okay, now we come up here and we got the graph there, and what's f of 4? So if I come over here and I go 1, 2, 3, 4 over, at 4, what's the height of this graph? So I got to go up here and, yeah, where's that height right there? So yes, if I plug in 4, right there, 1 over 4 minus 3 is 1 over 1. That right there has a height of 1. It's saying, what is it at that point? There's a solid dot right there at a height of 1. All right, approach. Okay, 0 from the left. Approach, 0 from the left. Okay, approaching it from the left. Driving along this road right here, approaching it from the left. And where do I end up? Negative infinity. Okay, I end up there at negative infinity. Okay, I approach it 3 from the right. Okay, so my car right here is going to be coming in from this direction along that road right there, and I want to get to 3. I'm getting, oh, right here's 3. As I get approaching 3, will I ever get to 3? No. Okay, so as I approach it, oh, I screwed that last one up. Yeah, our asymptote. Okay, our asymptote is not at 0 anymore. So, your rate switch is just did right there. As I approach it right here, as I get to 0, right here is 0. What is that height right there at that graph at 0? Because this is 0 right here. That's 0 right there.
1/3.
Okay, yeah, you're right. If I plug in 0 right here, okay, 1 over 0 minus 3 is negative 1/3. I am sorry about that. That height right there is negative 1/3. Okay, but I knew I caught myself because as I approach 3 from this side, this is the one that goes to infinity. Okay, because we're getting the asymptote. The asymptote move. Okay, so this has to go to positive and infinity right there. Okay, you go ahead and answer that one. A limit as we approach negative 3 from the left. So 3, from 3 is right here. 3 happens to be an asymptote. So we're coming in from the right. Okay, because it says come in from the right. Coming in from the right. This one down here says I want to do negative 3 from the left. So now my car's Okay, coming in from this side right over here. I always have a student or two that goes 3/4 of the way through this lesson. Why does he keep on talking about cars? If you guys at least watched the video lesson and you saw the cars, you know, what's that? We'll do horse stuff next. Okay? So, here we go. So we're coming in here and we're going to get to -3. Okay, so we keep, okay, we keep on coming in here. It's not an asymptote at 3, but it's at -3. So I have to plug in -3 in right there. And that's going to give me to a height of -1/6. Okay? How is it -1/6? Because I had to plug in -3, okay, right here. -3 minus 3. You can see at -3, 1, 2, 3. I'm like not very high at all. And that's why it's at -1/6. Okay? Right.
Mr. Johnson, what are the hot dog cars called?
Hot dog cars?
Wiener
Wiener cars? I don't know.
Wienermobile. The Wienermobile?
The Wienermobile.
This is where Gabe's mind
Yeah.
goes. I'm sorry. He all of a sudden goes from rational expressions. Well, I'm gonna ask him out of wieners. Okay?
Dude, the
Oh.
people at my table stars.
Alright. So we have, I know, I'm just giving you our, we got negative. Okay, well, they started with, horses. But I didn't ask to go to, horses to Oscar wieners. Okay, to,
Can we do a hot dog car in this one?
Sure, we can do a hot dog car.
And a horse?
Horse. We got a minus. We got a 4 over. X plus 8.
Go
Oh.
to an airplane.
An airplane? I'm good drawing airplanes.
Do a forklift. Do an excavator.
Forklift.
How about we just do this problem first? We're worried about what we're drawing next. I'm glad we're all worried more about what we're drawing than we actually learned. Okay?
I didn't know that was the Can we do it back?
Finding some funny pictures right now. Pickle style.
Alright, let's go. Cheers. You solved that one. Come on, go around. You got a graphic for this?
It's like an excavator.
Hey, graphic.
Sorry. I realized I just said escalator instead of excavator the second time. What am I doing? I do not know how to do this.
They're like the same thing.
I'm just here for the escalators.
So go and
Go
draw.
up forward and draw it back.
What? What are you on? It's revolutionary.
Simplifying crap.
Then turn it into like 1 over. Maybe.
Alright.
That's what
Could you graph 1 over x plus 8? Can you at least graph that?
Yeah.
Okay. What's this x plus 8 going to do? Okay. This right here. So we have an asymptote. Okay, that's going to be,
That's right.
okay, right there. Okay, and right there.
It doesn't draw that.
Okay, just for the sake of my graph right here, I'm going to move this all this way right here, so I have my work, okay, right there. So I have, okay, my asymptote there. So, what does this minus sign do to the function? A rocks. So this graph used to look like, okay, there's a point here that went up and over like that, point here goes over and down like that. That's if it's just a normal plus. So I have to rocks this thing. So if I come over here and I flip, okay, that one right, it just rocks it.
It's 47%.
Now, what does the 4 do to the graph?
Vertical stretch.
It's a vertical stretch. So this part of the graph right here should really be, okay, just dotted. Okay, so if I'm going to graph this, there's the parent, okay, right there. And if I'm going to stretch it out, okay, I don't really care about the exact graph. Okay, if I did, I'd just say, get a teacher, graph it all out. Okay, but that right there gives us the 4. Okay, so there we are. There's our graph, okay, of our function. We've roxed it, okay, and we've stretched it, okay, and we translated it left. Find f of negative 4.
No, it isn't.
Find f of negative 4.
We're for a couple of some
So if I go over here to negative 4, 1, 2, 3, 4, it looks like the graph's going to be somewhere in this region. I mean, this is just a sketch, so I can't just come down here and say, oh, it looks like it's at negative 2. Remember, my graph is just a guess. But I can come up here and say, if I plug in negative 4 right here, okay, that's going to give me negative 4 over 4. How far down should I have been at negative 4 right here if I did a really good job of graphing? I should have been, yeah, it should have been just coming up like that, okay, right there instead. Okay, so I'm right here at negative 1. That's the height at negative 4.
What is the best main picture?
You find that answer, I'll walk around and see how you did. Okay, find the limit as x approaches 8. It approaches 8. It's going to be a positive answer or a negative answer as it comes over here. It's going to be negative. Okay, so be careful as I do that right there. As I approach 8 right here, oh, that's negative 4 over 16, which is, okay, negative 1/4. Let's change this here now to, what happens if I approach negative 8? Okay, so approach negative 8, not positive 8, okay, but negative 8.
Negative 8 plus 8 is 0, and you can't have 0 on the bottom.
Yeah, why? I'm noticing you guys saying, oh, if I plug it in here, I'm going to get 0 right here, and I can't do that. Why is that happening?
Because 0 times something.
Yeah, if I start over here and I drive from here, from negative 8, as I approach negative 8 from the left, what's my limit going to be coming from the left? Positive infinity. But if I'm coming over here, approaching it from the right, what am I getting as I approach from the right? This is negative infinity from the right. So if I have this right here, okay, that does not exist. I'm going to change this though right here. I want to put a plus right there. So I'm going to approach negative 8 from the right. Does it have a limit now if I just want to approach it from the right? Kenny, what's it going to be as I approach it just from the right? Here we go. So we're going to have, this is coming in right here from the right. Drive along the road. Where's our height going to be at? Well, we get way down here at, okay, and it's right here, negative infinity. Okay? Sorry, I didn't have different ones.
Like a Wendy's coffee.
Okay.
Yeah.
Oh, I forgot.
Horses.
Horses on this next one. We got horses. We're gonna do it.
Cross them out.
Oh, yes.
1 over x minus 2.
What was I gonna YouTube again?
Limit does not exist.
Mean Girls. Limit does not exist. All right. You guys graph this while I see if I can find them. Mean Girls.
Yes, sir. It searched up me. Does not exist. I know it's not. What does it have? And what is going on? What? What? Oh yeah. It's like in a headburst and everything. He's gonna watch it.
I think I got it.
I thought I had it until they were all like surrounded by girls up and guys.
It was living proof that the more people are scared of you, the more flowers you get.
I don't know. It's like 6 things long.
Maybe skip forward. Just skip it until she's like at the competition. You should like, she's like all dressed up fancy.
Oh, yeah?
Yeah,
wait.
it would be like
It
this.
just doesn't.
Right.
Living.
There was a clip
I've
of
only
it.
seen it twice.
This is a movie?
Yes.
Yeah.
This all happened within like 2 hours?
You didn't know? That's on the movie.
No.
The 2002 movie.
Go through the pictures. I want to review. Buy this pickle.
And then you got these voices other people to buy it. You actually have to watch the film to get to that part. Yeah. To get to the full.
Alright, I found it. That was the last.
I didn't see it.
Alright. So, this one right up here. Okay, what's the first thing that you can do to make your life a lot easier here? Okay, cross that out. When I say when you cross something out, what does it create though? A hole. Okay, so we know that this part right here has shifted it to the right 2. So there's our horizontal asymptote. Or sorry, vertical asymptote is at 2. Horizontal asymptotes we're not going to deal with. Okay, it is, okay, right over here, a positive. So I got a little point here and it's going to go down. Actually, this one's not been stretched any, so the parent is right on top of the actual one. Okay, so there's my graph of my function. Okay, and it's going to look just like that. Except, what's missing on this graph still, there's a hole. Okay, there's a hole at where? Okay, remember how I tell you, okay, to always set it equal to 0? Same thing here. What you cross off, okay, you have a hole where x is -3. Okay, so we're going to come up here, okay, and go over to 1, 2, 3, and there is a hole right there in that graph. So this graph right here would go out like that, and would go down, okay, like that right there. Okay, now that's asymptote right there. If I asked you to find out, what is the function? What's the f of -3? Yeah, it's undefined. Because if I put in -3 into, remember you don't put it into the simplified one, because our graph that we're graphing right here is now 1 over x minus, that's the graph we have right here. But when we find the limits and we find the values of functions, we do it to the original function nodes. Okay, and if I plug in -3 here, -3 plus 3 is 0, and 0 times -5 is 0, and I have 0 divided by, I don't care what's up on the top, okay, right up there, okay, I get undefined. Okay, so this part right here is, okay, defined. Okay? Could I have a height at 2 though? Yes.
Isn't -3 plus 3 over top 0? Isn't this the 0?
0 times -5 is 0 on the bottom. Oh, on the top right up here? Yeah, that's why I didn't do it. Because the first thing that negates is you can't divide by 0, no matter what is up here.
Not even if it's 0?
Yeah, not even if it's 0. Okay, you can't find it. And then you can look right here. Okay, there is no value right there in the graph. There's a hole there, so that's why this right here is undefined. Now that's not good. 2. What is the height of the function at 2? You're right. Because there's not a hole there this time, but if I plug in, okay, 2 here, I get 2 minus 2 right here. That part's 0. Okay, this right over here, when I plug in 2 here, I'd have 5. 5 times 0 is 0. Now 2 up here would give us 5, but I didn't care what's on the numerator, because anything divided by that, okay, gives us, okay, undefined.
He's got so mad.
It was. Yeah, I just googled it. It was.
What's that? I know, I have it up there.
Okay.
It's, I'm going to pop it up here in this section.
Oh, yeah.
Okay? So, I have a limit as x approaches -3, okay, from the right. As you approach -3 from the height. Will there be a limit as I approach? There wasn't a value of -3, but will there be a limit as we approach it from 3? So we're coming from the right, okay, side right over here. So that means, okay, here's my wonderful little horse, okay, right there. And here is somebody riding the horse right there. Okay, here we go. Oh, don't want to do that. Okay, so I'm going to ride this horse. There we go. Giddy up. Right here, and we get to -3. Okay, and what is the height going to be at -3 when I get there? So that's when you're going to come up here to the simplified function right here. Okay, and if you plug in, I know if you plug in -3, don't you get undefined from this part? But if I want to know when I'm on the actual graph, which is this part right here, and I plug in, okay, -3 right there, in this part, what would be that height at that spot? Negative, okay, 1/5. And does that look like it's right around, really something small like -1/5? Because always look, if you get a height that's way up here, or you get it way down here, you got to think you did some math wrong. Okay, and so that right there is negative. Okay, 1/5. Okay, is your limit. Okay, as it approaches. Okay, from the right. Okay, now if I approach, okay, it from the left. Okay, so here we go. Okay, this horse is talented. It can run backwards. Okay, there we go. It's approaching it from the left. Does it make a difference if it approaches it from the left or from the right? No. Okay, a talented horse still gets -1/5.
I think it's a negative square.
Okay? Okay, how about 2? Let's approach 2 from the right. Okay? So we're coming over here on this graph right here, and we're coming in from the right. Okay, right here, and we're going to try to get to two's right here. But all of a sudden, we start, flying off the screen. So we go right. Oh, we bounce back. Okay, so we keep on going forever high. Okay, we don't want to hit our head and bounce back, but we know that right there is going to be positive infinity. Okay. All right. Scale of 1 to 5, where you guys out here, besides me, getting too crazy here with my drawings? Okay, alright, we're not doing too bad. We'll get Mean Girls out here while you copy that one down right there. Okay, and try graphing that one right there. Okay. We are. That's where I have the Mean Girls coming up. Mental break. Well, no, you're writing it down right now. So just write it down. Okay? And if you want to graph it while we watch Mean Girls, you can. Otherwise, we're taking a mental break. All right, let's check out.
It's like, dude, it's not my fault. He's like, no, we better
Calling somebody else fat won't make you any skinnier.
Hold on, I gotta get the lights on. We'll rewrite it so we can hear what she's saying.
What does that have to do with anything?
You guys are just watching this and you have nothing to know about it.
The limit is -1.
Dude.
Okay, here we go.
Yes, that's question.
Find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you. The limit is -1. Oh crap, we're lost.
The answer is incorrect. Now we are in sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why can't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh god, he looks so cute. Focus game. It was on the board behind Aaron's head. The limit never approaches anything. It does not exist. The limit does not exist.
Our new state champions, the North Shore Mathletes.
Yes. And then remember all about limits someday. Okay, you may have to remember about limits and some good-looking boy. That was the lights were. We had to watch down the whole thing in Mean Girls. It's fun. Back out in the background. Alright. What? She gets hit by a bus?
Yeah.
I think I have watched part of this. So your mental breaks?
Yeah.
I can definitely tell some of us are having a mental breakdown. Alright, this problem right up here. The main thing that I have to say, and this would be my Algebra 2 class, I always say, okay guys, who saves your day? And everybody screams out,
Something guy.
there we go, greatest common factor boy. What is the greatest common factor in the numerator? -7. Okay, and why do I want that -7 to be factored out? Because if I factor that out, whoops, I get x plus 2 in the numerator. Okay, I have x minus 1. So this thing right here was disguised as a very, very hard problem. Okay, but, okay, when we cancel that out, we're down to this graph right here that we're asked to graph.
There's a hole.
With a hole in it. Okay, so we're graphing that part right there. When we come up here and we start doing the limits, like this stuff right here, we'll do the limits of the original function, but this is going to help us, okay, find our graph, and it'll find some of our heights too.
just go to like Salvation Army, you play like 2 songs, and then go to
Yeah,
Punjab.
Because you walk out, that's a point.
Highlight of my life. Did you play like any band instrument in middle school?
Yeah, I just say that.
When you go to a concert, and then like after the concert, when you finish, you get taken to Lindale, and you just get to like roam around.
You're
We were supposed to stay in like the food court, but nobody really did.
And they did.
Alright,
Alright, first thing that I would do, I want to find an asymptote. Okay, so we know this asymptote right here, as we set this part equal to 0, okay, is at 1. So we put the vertical asymptote at 1. Okay, again, we're not doing anything with the horizontal asymptotes. Okay, here, I'll decide if we want to go that far sometime in the future. Okay, but right now it's right there. Okay, I know that this function right here has, okay, also then, if this right here is a minus, what else has happened to it? Okay, rocks. So that means that here's the parent right there, and I always go, this is where it's the normal parent, just goes to that 1, 1 spot. Okay, that's going to look like that. So there's your normal one. And this 7 right here is going to stretch that thing out. Okay, so we have a stretch of it. Okay, so this is just a quick representation of that graph right there. But what am I still missing? And this is the part you will always, when I say graph this is the part you'll always end up missing. Yeah, that hole. There's a hole in this graph. Okay, and that hole, okay, happens, okay, be at where x minus or plus 2 equals 0, so x equals -2. Okay, so we have to come over here to -2, okay, and we're going to come up to the graph, okay, right here, and put, okay, that hole right there on the graph, so our function, our graph would look like that, okay, right there. Okay, same thing over here. So there's my picture of my actual function with holes, with asymptotes. Okay, all there.
Also, when you're graphing the hole, you aren't doing it on the new one. You're just doing it on the old one.
I'm doing it on this one right
Yeah,
here.
but like when we added the new vertical line, how come we're not doing it off of that one? We're doing it on the old graph.
You're talking about the parent?
Yeah.
Because the parent has not been the part that's been transformed. The parent just tells us where we kind of go to and then form our graph from the parent. So the parent right here is just saying, okay, this is the type of graph it's going to be, but we've evolved from our parents, just like we have, to end up looking like this by stretching out.
But like, okay, so let me explain. So
Yes.
you know how we put the vertical line on the 1?
Yeah.
That one, how come we aren't like going off of that one -2? How come we're going on the old graph -2? You know
So you're saying
what?
right here on this part?
Yeah.
So put it right there?
Yeah, how come we're going off the
Because because this dotted one, okay, so this dotted one right here is this, the dotted one, that's the graph of the dotted,
Okay.
okay? And if I put in, okay, -2 there, will that create a hole at -2 on the original graph? No. So there's no holes on the parent,
Okay.
okay? You know, just like we're a little different from our parent. Okay, this one right here is similar, but it has a hole in it where the parent did not have.
Okay.
Okay, that makes sense?
Yeah.
That's a great question. All right, so we're down here, we have this function right here that we have to graph. Okay, we graphed it. Okay, any other questions before we go on our graphing?
So we have like the original graph, like this,
Uh-huh.
and it moved over, one of the asymptotes moved over 1. So why wouldn't we go to just -1 line over 2? When you go, yeah.
So, you're talking about the hole?
Yeah.
Because the whole has to be formulated after there's orders of operations that have to occur as well. And that's one of the operations that you want to find first, is you want to shift those asymptotes first, find the parent, then find your holes from it. So if you find a hole right here at -2 first and then shift it, okay, you're violating your own regulations.
Not quite.
No?
I mean, like, that's kind of.
Yeah, you're welcome.
What's your sign? And then, what's your mom?
See, you're really looking at Mean Girls to see how well it was.
Okay, so we have this right here, and then we also have like the original graph.
Uh-huh.
So when it's up here, why not go over to from there? Why go from
Because the hole has to be shifted where x is -2.
Okay.
That's the only part. It doesn't matter about anything else. Where x is -2 creates a hole because when x is 2, that becomes 0 there. If I just went over 2 from here, 1, 2 over from that, that'd be -1. If I put in -1, that doesn't cause any problem. So that is not some question there. But the hole is not the thing that's being, shifted. Okay, it's the graph that's being shifted. Okay? The hole stays constant at that value of wherever x is -2. Okay? Alright. So we're finding f of 1. Okay, so I'm over here at 1.
Pardon me, nearby.
There
Yeah.
is no limit.
There is none right here. There's undefined. How about if I go over to 2? Will there be a height at 2? 2 is just finding the height of the graph at 2. So if I go over to 2, what's that height going to be right here when x is 2? Okay, well that's where I have to come over here and I got to plug 2 into the graph. I got a 2 right here, I got a 2 right there. Okay, and I have to put a 2 right up here into that graph. Now, since I'm only trying to find the height of the function anyway, you can do it all right here, okay, in that function. You can also, okay, come over here to this one that I have right here and put the 2 right there, okay, because we know there's no restrictions at 2. There's nothing at 2. So this is going to be -7 over 1, okay, right there, which, okay, is going to come up with a value of -7. Oh, is that right? -7. So this spot right here at 2, that's the parent. But if I go down, 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 you guys see how it's way down here is where the spot is? Now this was just a sketch. And some of you are looking at it and said, that's not -7, that's -9, because I just threw something up there. So this graph right here at 2, okay, right here should have been going through -7 right there, so the graph would have been like that a little bit more. So we're right here at -7, okay, at that spot. Oops. Okay, so that part is -7. Just trying to find the height there.
Yeah.
I did, but I will get the same thing if I come up over here. 2 minus 1 is 1. 2 plus 2, okay, here is 4. Okay, this part right over here is going to give me -14, -14 minus 14, which is -28. -28 divided by 4. What's -28 divided by 4? Yeah, this part right here has just been reduced over here. I hesitate to use this one because there's sometimes that when you have asymptotes and holes, this causes problems. This will never fail over here. It just gets all bigger numbers and uglier numbers. Find the limits. Okay, as x approaches. 1 from the left. Okay, so we're approaching, okay, right over here from the left. Okay, so I don't know how to make a Oscar Mayer wiener dog little deal right there. There we go. We got an Oscar Mayer wiener little dog right there. Okay, driving it right over here. Okay, from this side right here, we're coming in. Oh man, he doesn't like to drive. He just falls apart. Okay, so we're driving in and we're getting to 1. Okay, so we're coming this way, we're getting to 1, and what's going to happen as we get closer to 1? We go up to, okay, positive, okay, infinity. Okay? You guys are making fun of my picture stuff? How about 2? If I come in from 2 from the right. Okay, so here's my Oxmeyer wiener dog coming in from 2 from the right. Driving from the right. What's going to happen when I get to 2? Okay, I plug it in. Is it going to give me any different than I plugged it in for this one right here? No. It's still going to give me, okay, a height of -7. What happens if I change this and I don't say come in to 1 from the left? I just say approach 1, period. So that means I have one of them approaching 1 from this side, okay, and then we have another one. Oh yeah, 2 blocks. Okay, so one's coming in this way, and one's coming to 1 this way, and what's our limit going to be at? Okay, the hole. Okay, the hole does not stop them from approaching 1, because I can essentially start from here.
You have an extra time.
Okay, so this right here, okay, does not exist right here. Okay, now what happens if I put a -2 here, and I approach -2 from the right? Coming over here, approaching it from the right. I get to -2. Is there a limit going to be right here at -2? It doesn't say what it equals at -2. It just says what's the height as it approaches -2. So I have to plug in -2, okay, right up here, which I can do the same thing right here. I can plug -2 in here. That's going to give us -3 right there, and -7 divided by -3 is about 2 1/3. See how I got 2 1/3 right here? Well, let's take a look. As I'm coming in right here from the right, okay, so I'm coming in from the right, okay, this graphic, you can see right now, I graphed it too wide right here, because that should be right up here at this hole, okay, right here should shift down a little bit, okay, right there to my graph, and it comes in at a positive 7/3. Okay, positive 7/3. Alright. Your exit ticket right here. Okay, see we're losing it. Okay? There you go.
No, you can simplify it down very far.
On the paper or on the whiteboard?
On your graph, on your sheet of paper. Okay, this is your exit one right here.
Do we just have to graph it?
It's going to be first. That's your first thing, and then there will be some things after.
Can I get on my whiteboard?
I know, because I need you to have something for notes for your. You had a couple problems for tonight. Okay, I'm going to show you, yes. Okay, but that's your exit one right there.
Oh, yeah. Uh-huh. I'm going.
I guess you just couldn't skip over it.
Just the front. Save the best for last, Jody. Just the front.
Because the inverse of x squared is.
Factors of 3 and 4.
Well,
Just the front. Okay,
Oh, thank God, I didn't read it.
just the front. I know.
but amplitude, can't you just cancel it?
Except the first one, I'm actually gonna do it.
And then could you cancel these two? So those are the same.
I don't know.
Yeah.
So, for me to ask you to graph this is nuts, okay? But it does simple. First thing I would, and this is how I would cheat. Okay, it's not cheating, this is being smart. Who saves your day? Okay, if I factor that out right away, you guys see how I have an x plus 6 here? I would automatically say, maybe there's an x plus 6 down here. Is there an x plus 6 that goes down here? No. Okay, so this part right down here, okay, is, oh, that is not even factor. Okay, what did I do on this one right here?
That's what I'm thinking. It should be 3 in the middle, right?
Let me, I just looked up on my problem right here. So this part right up here is going to factor to x minus 4, x minus 3. Okay, and
You got 5 minutes to figure it out.
That's what I'm saying.
hold on, just let me think. It's supposed to be a 24.
Right here. I'm so sorry.
Oh, I see what it is, yeah.
That's what's supposed to be right there. Okay?
Whoa.
It's supposed to be a minus 24.
Chill.
Okay, so what I was getting at right here is before I did all of this right here, the first thing I would do is okay, if I'm not good at factoring, here's how I cheat. I see there's an x minus plus 6 here, and I'm thinking, man, I just hope there's an x plus 6 out down here so that it factors out. Could 24 have a factor that has 6 in it? And if it did, okay, have a factor right here, okay, of 6 in it, x plus 6. What would the other factor be right over here that would give us negative 24, and hopefully the insides and outsides give us negative 2, or positive 2? X minus 4. So then that comes up here to say to me, okay, that's awesome, okay, because those cancel. And now, okay, I'm going to come up here and I'm going to look at this graph right here and I'm going to say, oh, now I got this thing. Maybe it factors. Maybe there's an x minus 4 that factors up here and maybe that'll cancel out. Could a 4 go into this 12 right here?
Yeah.
And if I do have an x, now it may not cancel, okay, but if I did that, what would be left for the other factor? That would be right over here. That gives me positive 12 x minus 3. And then this is like cool. And what am I left with is I have f of x equals 2 times x minus 3 over 1, which is really just f of x equals 2x minus 6. And what type of graph is this? Oh. So man, I mean, your x is easy. It's just a line. It doesn't have to do asymptotes. You do still have some holes. Okay, so we're graphing this thing, and we come up here, we find negative 6. Okay, we got negative 6 there. I rise 2, run 1, rise 2, run 1. Okay, here's my graph. And the biggest thing that you will forget, okay, yes, I have the x-intercept there. But what's the biggest thing you're always going to forget? The hole. Okay, one of the holes that we have is at where x minus 4 was equal to 0. Another one of the holes that we have was where x plus 6 was equal to 0. So the biggest issue that I have right here is I want to label this hole. So if I go over 4, what's the height going to be right up here when I find this spot right here at 4? You want to plug it into this graph right here? What's 4 times 2 minus 6? This hole is at 4 comma 2. So there we go. We have a 4 at 4 comma 2. I come over here and I solve this other hole. I have x equals -6. If I plugged in -6 into this function, I got -12 minus 6. Way over here at -6. I'm way down here. How far down am I?
Way.
-18.
-8. So there's one way down here at, okay, -6 comma -18. Okay? I'll just remind you that we stopped here. Okay, I'll finish up here on Thursday. Okay, and I told you just to put it up. Everybody got a worksheet, right? Just to put it. 4 problems there on the front. Obviously, there's 4 limits, but the limits aren't the hard part. Drafting's the hard part.
I don't like the practice.
Make sure you do the practice on these, otherwise the next lesson's gonna be worse.
I'll probably copy and paste some stuff.
If you gave us an outline, then I would follow that. That's what you do.
Yeah, I'm gonna just
Are you pretty good?
let's sit down and say, I want to
Oh, Landon,
just for your thoughts.
how you doing?
Awesome.
I mean, my mom's really
Yeah, it's
me
okay.
out for the whole day.
There's 2 Lexuses here.
Yeah, they want some sort of like the same model. Here goes that speed extravagant. I was basically oh, it's never been like wait.
And then Friday, I'm not gonna be
I was like 20 minutes late.
Like oh, it's still the same thing.
the college.
We're out.
Yes. Go school.
Monday? Okay, so I'm not 100% sure where we're going to get to on this, but we'll be doing piecewise functions. Okay, so the next 2 worksheets on piecewise functions is, I believe, what we'll try to get to. Okay, but I kind of have to see what Thursday brings and what we're having. Okay, right there. You can take a picture of what I think we're going to do. Okay, right here. I got it written down.
Is this the front?
That's the front. Okay, so we're gonna work on worksheets 1 and 2 right there. That's on Thursday. Right on. And you said next week we're gonna be finishing up on piecewise worksheet right there, and then I'll have another rational stuff right there. Okay?
Thank you.
Yep.
So why can't the holes be asymptotes?
Because the holes don't define the point to be undefined completely at that spot. They define the point that doesn't exist at that one. There's no height at that spot. There's a little bit difference of the graph how it approaches those things. It just a hole just is a little bump in the road. An asymptote is something that it just keeps on getting closer and closer and closer to. Okay, that will never touch.
I was on time today. You were, I was very proud.
Yeah, that competition. You have to win the competition. And they said it did not exist. Is that what they were talking about? Of course they did. Yeah, you got a download copy here. Yeah.
So, maybe you can make up there, right?
Yeah.
So, no ballot?
Yeah.
Don't do that.
Cookies, did you bring them? Oh.
You just love that it has people registered for something. Well, empty or vacant? Which of course I mean, of course, you can't have the two. I'm like, come on, everything was formal out, I'm sure you can keep buying.
Yeah, I wouldn't say it was good.
Because we didn't send them to,
Oh, definitely.
feel like they were like, so like let me know ahead of time. Going to the dentist, going to the doctor, in the beach doctor. So I want like, I'll give you a prime example. Why I like them up. Yesterday, daycare, downstairs, whatever. Mom, I have a surprise for you. Okay. He got to me. Downstairs, into his bedroom. I made all the beds. Then his dad, he made all the beds. And I'm like, what did you do? He's like, I don't know. I just came out and I saw them and I realized he did that. You, my boy. You're a kid. Like that.
It's always going to be the way to.
Oh my God. Good job, like for all these things. And then he's gonna be.
You girls will always.
Look like full health. Yeah. I mean, I want them to be strong and independent. So I got like Tunisia. Do these yesterday. You came home and you're doing hey guys, you're not big on I love you. There's I don't love you. I don't love mommy. No problem. Well, whether you feel it or not, you should not say it out loud. You just I don't care that you feel that way. But that is not kind to say to somebody. Yeah, she ended up being fine. Yeah, reason number one, that was my husband's my favorite. Yesterday, he came home and he goes downstairs and he does something and he says, I got a surprise for you. That's what I got. Mom, I made all the beds. I was like, oh, what did you do that for? I got my mom, so I should make the bed. You. Where's Genevieve? She's home. Jerry's like, hey, Genevieve, how's your day? I love you. She goes, I don't love you. I only love mommy. Oh. And I was like, well, you go time out. Whether you feel it or not. You don't talk like that. You don't say that to somebody. That hurts their feelings. So you go sit time out. Gosh. Hey! Yeah. That's our kid, I tell you. In my family, the second kid was. In my family, the second one was a boy. Jared picked on me and so. Yeah. Oh, really? She ended up. Do you think you'll lean into her more then? Did I miss anything yesterday? Important
For our meeting?
for that and like you guys on Friday, well not maybe, but on Friday they were supposed to talk about who's gonna teach what when everybody retires. Did they say anything at lunch about that?
Not really. Were we supposed to do something for the ACT take? Watch something or a video or
Well,
something?
for the ice
That's what I mean.
pass, there's a 74-minute video and a 4-minute video.
And I had to watch those?
And you can have it there and do other things, but you have to watch them.
Where's that link at?
I'll send it.
Is it on the,
It's an email.
it's an email?
Yeah. You want me to send it to you?
Yeah, it might be on the staff page or the testing and whatever that's there.
It might. I just.
So, yeah, I gotta do that. It's right there. And you said that, and there's a 4-minute one too?
Yeah, so the 74 minutes, like, general, and then the 4 is for, like, the adaptations. Jason goes, most of it's not relevant to you, but state doesn't care, so you have to watch the whole thing. I was like, okay. But, yeah. And then we have to give another survey this Friday. That just came in today.
And when we give it in homeroom?
6.
Friday we have to give it?
Yeah.
6:30. Why wouldn't we do it in homeroom?
It's like that other one that we gave last
Yeah, I
time.
know.
Yeah,
Why?
I
We're in
don't know.
homeroom. Because they know people don't go to homeroom or what?
Probably. This period's longer.
It is, but we have homeroom. That's what the whole purpose of homeroom is, to do organizational things like that.
Yeah, but I don't know if teachers really use homeroom for that. What's this class, or what's this for? What class? Ah, that's why it looks so confusing.
Alright, did you get all done with your math test?
No, I haven't yet, dude.
Okay, is that what you're waiting for me for?
Mm-hmm. The heck? Oh. Wait.
glasses. I was like, I just had them in my pocket. Yeah, I put them on the desk. That would make sense of why I couldn't find them.
Don't worry, I just lost my glasses. Just sitting out here somewhere.
Somewhere. My mom always loses her glasses. But, like, glasses are glasses.
They're just reading glasses.
No, she always loses them, but half the time they're on her head.
Yeah. Um. Alright, there's your username and password. Got it, Sam?
Yeah, it's on.